But picture this: Daytona Beach, February 1955. A grease-stained mechanic with a cigar clamped between his teeth walks up to a Chrysler 300 with a fistful of Radio Shack magnets and some electrical tape. Every Chevrolet team on the beach is laughing. 3 hours later, those same Chevys are eating sand while the Chrysler disappears down the beach at speeds that shouldn't be possible. The mechanic, Smokey Yunick. The trick? Something so simple, so weird, that even today, engineers appear to argue about whether it actually worked, or if Smokey was just messing with everyone's heads. 1955 Speed Wars. The year is 1955, and American automotive is in the middle of a full-blown horsepower war. General Motors has just dropped the small-block Chevy V8 on an unsuspecting public, and it's absolutely demolishing everything in its path. 265 cubic inches, producing 195 horsepower. That might sound pathetic today, but in '55, it was like strapping a rocket to a refrigerator. Light, powerful, and most importantly, cheap enough that every teenager with a paper route could build one. Chrysler, meanwhile, had a problem. Their Hemi 5.8, the engine that had dominated NASCAR just 2 years earlier, was suddenly looking old and tired. The firepower Hemi was huge, 331 cubic inches, making 250 horsepower. On paper, it should have destroyed the Chevy, but the Chevy was lighter, revved higher, and most importantly, it was winning races. The Hemi was becoming a dinosaur in real time. Here's what made it worse. The Hemi wasn't just losing, it was getting embarrassed. At tracks across the South, Chevys with high school kids driving were outrunning factory-backed Chrysler teams. The engineers from Detroit would show up with their clipboards and stopwatches, make some adjustments, and the cars would get slower. It was humiliating. Chrysler's legendary Hemi, the engine that had made them the performance king just 3 years earlier, was now the automotive equivalent of bringing a knife to a gunfight. The problem wasn't the engine's basic design. The hemispherical combustion chambers were still brilliant. The valve train was robust. The bottom end could handle abuse that would grenade a Chevy block. But something was wrong with how the engine made power at high RPM. Above 5,000 RPM, the Hemi would just flatten out. Like hitting a wall, the power would peak and then drop off a cliff. Meanwhile, Chevys were screaming past 6,000 RPM like it was nothing. Chrysler's engineers knew what the problem was, sort of. At high RPM, the ignition timing was becoming erratic. The spark plugs were firing, but not at exactly the right moment. Sometimes they'd fire too early, sometimes too late. This timing scatter was costing horsepower, maybe as much as 30 horses at peak RPM. But here's the thing. With the technology available in 1955, there was no good solution. Distributors were mechanical devices. Points opened and closed, springs controlled the advance. Everything was analog. And at high RPM, everything got sloppy. Detroit's solution was typical: throw money at it. Better distributors, precision machining, tighter tolerances. They spent thousands of hours on dynamometers, testing every conceivable combination. Nothing worked. The spark scatter remained. The Hemi kept losing to Chevys. And the engineers kept their jobs while the cars kept losing races. Oh, enter Smokey Yunick, the genius nobody wanted. If you don't know who Smokey Yunick was, let me paint a picture. This was a guy who once entered a Chevelle in NASCAR that was 7/8 scale. 7/8. He literally built a car that was smaller than the actual production car, making it lighter and more aerodynamic, and somehow convinced inspectors it was legal for an entire season. When they finally caught him, measuring tape in hand and faces red with embarrassment, he drove the car out of the inspection bay without the gas tank to prove a point about their rules. Just fired it up and rolled away, leaving a trail of fuel on the ground, and inspectors arguing about whether that was even possible. Smokey didn't just bend rules. He folded them into origami, set them on fire, and used the ashes as valve grinding compound. Smokey had started as a B-17 mechanic during World War II, keeping bombers flying when half the parts were missing and the other half were held together with wire and prayers. That experience taught him something Detroit engineers never learned. Function beats theory every single time. After the war, he opened a garage in Daytona Beach, Florida, right on the beach where they raced. This wasn't some fancy motorsports facility with computerized equipment and white coats. It was a cinder block building with a sand floor, a ceiling that leaked when it rained, and equipment held together with coat hangers, spite, and the occasional weld that probably violated several laws of physics. The place looked like it should condemn itself. But Smokey understood engines in a way that college-educated engineers with their slide rules and textbooks couldn't comprehend. As in, he didn't calculate airflow with that fancy equations. He felt it, like reading Braille with his fingertips covered in motor oil. He didn't measure compression ratios with gauges. He listened to engines the way a doctor listens to a heartbeat, and he knew what they needed before the first spark plug came out. People thought he was crazy. Turns out he was just smarter than everyone else in the room, which probably amounts to the same thing. By 1955, Smokey had built a reputation as the guy you went to when conventional wisdom failed, when the factory engineers had given up, when your race car was slower than your wife's grocery getter, and you were ready to push it off a cliff. He'd made inline sixes competitive with V8s, which was like bringing a knife to a gunfight and somehow winning. He'd taken broken, obsolete engines that belonged in scrapyards and turned them into race winners. His methods were unorthodox, which is a polite way of saying he did things that made professional engineers physically uncomfortable, like watching someone eat soup with a fork. But he won races, consistently, embarrassingly, and in 1955, when a wealthy Chrysler dealer showed up at his shop with a 300 that couldn't beat Chevys driven by teenagers, Smokey didn't see a problem. He saw an opportunity. He saw money. The car was a '55 Chrysler 300, the hot rod version of Chrysler's luxury boat. It had the 331 Hemi, a 3-speed manual transmission, and enough chrome to plate a battleship or blind every driver within 3 counties on a sunny day. The owner, a wealthy dealer from Atlanta who wore suits that cost more than most people's cars, had tried everything. He'd sent the car to Chrysler's engineering department in Highland Park. They'd blueprinted the engine, balanced everything down to the gram, installed a high-lift cam that cost more than Smokey's dyno. The car was still 2 miles per hour slower than Chevy's at Daytona Beach speed trials. 2 miles per hour doesn't sound like much when you're driving to church on Sunday, but at that level of competition, it might as well be 20. It was the difference between winning and being a footnote. Smokey spent 3 days with the car, just driving it, listening to it, feeling how it responded to throttle input and load changes. He didn't hook up computers because they didn't exist. He put it on his dyno, which was basically a drum connected to a bunch of water pumps he'd salvaged from a fire engine auction and welded together with faith and fury. The car made 243 horsepower at 4,800 RPM respectable. Above 5,000, power dropped to 225, not respectable. Classic Hemi problem, spark scatter. The engine was lying to itself about when to fire. The magnet discovery. Accidental genius. Here's where things get interesting. Smokey didn't have access to oscilloscopes or electronic timing equipment. He had a timing light, a dial indicator, and his brain. He spent 2 full nights in the garage, chain-smoking cigars and staring at the distributor. The problem, he knew, was mechanical slop. At high RPM, the distributor shaft was wobbling, just a tiny amount, maybe a few thousandths of an inch, but enough to make the points open and close at slightly different times. The conventional solution would be to build a better distributor, tighter tolerances, better bearings, stiffer springs. That's what Chrysler's engineers were trying to do. Smokey thought that was stupid. Why fight the wobble when you could control it? On the 3rd night, working on a completely different car, Smokey accidentally dropped a wrench. It landed on a pile of magnets he'd been using for some kind of magnetic drain plug experiment. The wrench stuck to the magnets, obviously, but here's what made Smokey's brain light up. The wrench, even though it was vibrating from the engine running nearby, stayed perfectly centered on the magnet. The magnetic field was stronger than the mechanical vibration. What if, Smokey thought, you could use magnets to stabilize the distributor shaft? Now, before we go further, let me explain why this idea was absolutely insane by 1955 standards. Magnets and electrical systems don't mix. Every mechanic knew this. Stray magnetic fields could interfere with ignition, cause short circuits, scramble radio signals. There's a reason auto manufacturers went out of their way to keep magnets away from distributors. Putting magnets on a distributor was like putting water in your gas tank. It violated every principle of automotive electrical design. But Smokey didn't care about principles. He cared about results. He took apart the Chrysler's distributor and studied the shaft. The shaft rode in a bronze bushing at the top and a ball bearing at the bottom. At high RPM, the shaft would start to resonate, wobbling like a jump rope. The points were mounted on the shaft, so when the shaft wobbled, the points opened and closed at inconsistent times. Hence, spark scatter. Smokey's idea was beautifully simple. He would mount small magnets around the distributor, housing at the top bushing. The magnetic field wouldn't be strong enough to affect the points or the spark, but it would be strong enough to dampen the shaft's wobble. The shaft, being steel, would be attracted to the magnets equally from all sides. This would center the shaft and reduce vibration. The technical execution, how it actually worked. The execution was almost comically crude. Smokey didn't machine custom parts or order specialized components from aerospace suppliers. He got in his truck, drove to Western Auto, and bought 8 small magnets off the shelf, the kind you'd use to stick your kid's report card to the refrigerator. They were maybe half an inch in diameter, 1/4 inch thick, ceramic with a steel backing, cost about 35 cents each. The clerk probably thought he was buying them for a school science project. Back at the shop, Smokey stripped the distributor housing down to bare metal. No fancy prep work, no cleaning solvents, just a wire brush and elbow grease. Then he started placing the magnets. First, 4 magnets spaced 90 degrees apart around the top, bushing where the distributor shaft entered the housing, north pole facing in, creating a circle of magnetic attraction around the shaft. Then 4 more magnets offset 45 degrees from the first set, filling in the gaps. 8 magnets total, creating a uniform magnetic field around the shaft, like invisible hands holding it steady. The attachment method? Electrical tape. Not even good electrical tape. The cheap stuff that gets gummy in the heat and falls off after 6 months. Smokey wrapped each magnet individually, then wrapped all 8 together in a band around the housing. It looked like something a high school kid would build for shop class. Professional engineers would have used precision brackets, calculated mounting forces, run finite element analysis on the magnetic field distribution. Smokey used tape from a drawer that probably also contained rubber bands, rusty screws, and a sandwich from last Tuesday. The whole modification took 20 minutes and cost about $3. Chrysler had spent probably $50,000 trying to solve the spark scatter problem with precision distributors and tighter tolerances. Smokey solved it with $3 and a roll of tape. He buttoned up the distributor, being careful not to knock any magnets loose, and reinstalled it in the engine. The electrical connections went back exactly as they had been. No modifications to the points, no changes to the advance mechanism, nothing else touched, just 8 magnets taped to the outside of the housing. He connected the battery, hit the starter, and the 300 fired right up. It sounded exactly the same. No weird noises, no electrical issues, no mysterious humming or bizarre vibrations. Smokey let it warm up, watching the oil pressure gauge and listening to the valve train. Everything normal, then he started revving it, slowly at first, letting the RPM climb, 3,000, 4,000, 4,500. At 5,000 RPM, right where the power normally fell off like driving into a wall, the engine kept pulling, the tachometer kept climbing. 5,200, 5,500, 5,800. The engine sounded angry, like it had been constipated for months and finally got relief. Like it was saying, "This is what I wanted to do all along, you idiots." Smokey backed off the throttle, let it idle, then did it again. Same result. The engine revved freely past 5,000, past where it should have been choking on its own spark scatter. He walked around the car twice, looking for something he'd missed. Some explanation that didn't involve refrigerator magnets solving a $50,000 engineering problem. Nothing. The car was the same. The magnets were the difference. He put the car back on his janky dyno, the one held together with water pumps and hope. First, a baseline pull to 4,800 RPM, where the engine had always made peak power, 243 horsepower, same as before. The magnets hadn't heard anything. Then he let it rip. The engine screamed past 5,000. At 5,500 RPM, where it had been making 225 horsepower and falling, it now made 258 horsepower. At 6,000 RPM, a speed the Hemi had never sustained before without eating itself, it was still making 245 horsepower. The Hemi had found 33 horsepower just by stabilizing the distributor shaft with refrigerator magnets. 33 horsepower that had been there all along, trapped behind mechanical vibrations that nobody thought to solve with $3 worth of hardware store junk. Smokey walked to his office, picked up the phone, and called the dealer in Atlanta. The conversation was brief. "Bring money," he said, "and don't tell anybody what I'm about to show you." He hung up, lit a cigar, and stared at the Chrysler sitting in his garage. Sometimes, Smokey thought, the best solutions are the ones nobody's stupid enough to try. Daytona Beach, February 1955. Daytona Beach in February 1955 was the center of the automotive universe. This was before NASCAR built the superspeedway. The races were run on the beach itself, a 4-mile straight down the hard-packed sand, a turn through the dunes, then 4 miles back up Highway A1A. It was primitive, dangerous, and absolutely spectacular. Every manufacturer fielded teams. Every hot rodder with a fast car showed up. You'd have factory-backed Chryslers lined up next to someone's garage-built Ford. Democracy through speed. The Chevy teams showed up confident, bordering on cocky. They'd been dominating the beach trials for months. Their new V8 was the engine to beat, and they knew it. The fastest Chevy, a Bel Air with a mild cam and dual exhausts, had run 137 miles per hour the previous month. Chrysler's factory team had managed 134. 3 miles per hour might not sound like much, but on the beach, with crosswinds and soft sand, it was enormous. Smokey showed up on Friday morning with the 300 on a trailer. He didn't say much, just unloaded the car, checked the tire pressures, and waited for his runtime. The Chevy guys noticed the Chrysler, but didn't pay much attention. Just another heavy Mopar about to get embarrassed. The first run was at noon. Smokey did a standing start quarter-mile first, just to make sure everything was working. The Chrysler ran 14.2 seconds at 98 miles per hour. Respectable, but not scary. Then came the flying mile, where cars got a rolling start and hit the timing traps at full speed. Smokey went through his pre-run routine, checked the oil, checked the distributor magnets to make sure they hadn't vibrated loose, warmed up the tires. Then he staged at the south end of the beach, where cars got a 2-mile run up to the timing traps. He launched the Chrysler in first gear, winding it to 6,000 RPM before shifting to second. The Hemi screamed. At 6,000 RPM, it sounded like tearing metal, but it kept pulling. Into third gear at the timing traps. The car was doing about 145 when it crossed the finish line. The timing crew flagged the result. In 147.3 miles per hour, the Chevy teams thought it was a timing error. No way a 300, a heavy luxury car with stock bodywork, could run 147. The fastest Chevy had run 137. This had to be a mistake. Smokey made 3 more runs that afternoon. 146.8, 148.1, 147.6. Average speed, 147.5 miles per hour. 10 miles per hour faster than any Chevy on the beach. By Sunday, every team wanted to know what Smokey had done. The assumption was massive engine work, overbore, stroker crank, radical cam, maybe nitrous. Smokey being Smokey let them speculate. When officials asked to inspect the car, he popped the hood and showed them a completely stock 331 Hemi. Stock bore, stock stroke, stock cam, stock heads. The only modification was a high-flow air cleaner and dual exhausts, both legal. Nobody thought to check the distributor. Detroit's reaction and denials? The Chrysler dealer from Atlanta was thrilled. He'd entered the car in the manufacturer's trials and won the Chrysler class by margins that made headlines. Smokey billed him $800 for engine optimization, which was $1955 money for, "I did something nobody else figured out." But here's where the story gets even better. Word started spreading through the garage area about the fast Chrysler. By Monday, 3 other teams had hired Smokey to work on their Hemis. He performed the same modification on all 3. 8 magnets arranged around the distributor bushing. Every single car gained between 25 and 35 horsepower at high RPM. Tuesday afternoon, a GM engineer showed up at Smokey's shop. He wanted to know what Smokey had done. Smokey, never one to miss an opportunity, told him the truth. "Magnets," he said. "On the distributor." The GM engineer looked at Smokey like he'd grown a second head. "That's impossible," he said. "Magnets would interfere with the electrical system." "And yet," Smokey said, pointing to the timing slips on his wall, "here we are." The GM engineer went back to Detroit and told his superiors. They didn't believe him. A full team of GM engineers descended on Daytona the following month to investigate. They inspected one of Smokey's modified Hemis, removed the distributor, and saw the magnets. They took the distributor back to Detroit for analysis. According to people who were there, the GM engineers spent 3 weeks testing the magnetic distributor modification on their dyno. Their conclusion? It worked, but they couldn't explain why. The magnetic field shouldn't have been strong enough to affect the shaft. The magnet shouldn't have improved spark timing. By all conventional theory, this modification should have done nothing, and yet, every test showed power gains at high RPM. GM's official response was to dismiss the modification as a fluke. They released a technical bulletin stating that magnetic fields near distributors were dangerous and could cause electrical failures. This bulletin was pure cover-your-ass engineering. They couldn't explain how Smokey's trick worked, so they declared it unsafe. Other manufacturers took notice, though. Ford engineers quietly tested magnetic distributor damping in 1956. Their results matched Smokey's. Pontiac experimented with similar modifications. Even Studebaker, barely clinging to life as an automaker, tried it. By 1957, several racing teams were using magnetic distributor stabilization, though nobody called it that. They called it the Smokey treatment, or Yunick's magnets. NASCAR finally got involved in 1958. Officials ruled that magnetic modifications to distributors were illegal under the stock car rules. The reasoning was deliberately vague, something about maintaining manufacturer specifications. In reality, NASCAR was tired of tech inspectors arguing with teams about whether refrigerator magnets counted as performance parts. The broader impact on engine design. But the genie was out of the bottle. The principle that Smokey had discovered, that mechanical vibrations in distributors could be controlled with magnetic fields, became foundational to later ignition system development. It just took the industry 15 years and millions in research funding to rediscover what Smokey had figured out with a dropped wrench and $3. When Chrysler developed their electronic ignition system in the early 1970s, the one that would revolutionize how cars started and run, guess what they used to stabilize the reluctor wheel? Magnetic dampening. Not exactly the same as Smokey's setup, obviously. They had engineers with degrees and budgets and computers, but the core principle using magnetic fields to control mechanical vibrations and rotating components, that was pure Smokey. When GM created their Hazy Energy ignition system, the HEI that would become legendary for reliability, they incorporated magnetic stabilization in the design. Ford followed suit. Even the imports, Toyota and Datsun, used similar principles when they developed their electronic ignitions. Nobody at these companies admitted they got the idea from Smokey Yunick and his refrigerator magnets. The official histories talk about research and development, about teams of engineers working through the physics, about breakthrough moments in corporate laboratories. They don't mention a grease-stained mechanic in Daytona Beach taping magnets to distributors with electrical tape. But the patents tell a different story. If you dig through the USPTO archives, looking at ignition system patents from the 1960s and 70s, you'll find references to magnetic vibration, dampening, and rotating shafts. The dates line up perfectly with when Smokey's trick became common knowledge in racing circles. Coincidence? Sure. And I've got a bridge to sell you. Here's the technical reality of what Smokey had discovered, as near as modern engineers can determine. At high RPM, distributor shafts experience something called coupled resonance. The shaft vibrates at its natural frequency like a tuning fork, which creates secondary vibrations in the points and condenser. These secondary vibrations cause timing scatter, where the spark occurs at slightly different crank angles from the cycle to cycle. Even a variance of 2 or 3 degrees is enough to cause significant horsepower. At 6,000 RPM, the engine fires 50 times per second. A 3-degree timing variance means the combustion is happening at random points in the compression stroke. wasting energy and creating heat instead of power. Smokey's magnets created a weak magnetic field that interacted with the steel distributor shaft. This field didn't prevent the shaft from rotating, obviously, or the engine wouldn't run, but it did dampen high-frequency vibrations. Think of it like magnetic shock absorbers. The shaft could still move up and down for normal operation, following the cam lobes, but the wobbling, the resonance, was suppressed. The magnetic field acted like invisible hands, keeping the shaft centered without adding friction. The reason it worked better than mechanical solutions was elegance. You weren't adding mass or friction to the shaft. You weren't changing the fundamental dynamics of how the distributor operated. You were just dampening specific vibrations, using a force that conventional mechanical engineering couldn't address. It was genius because it was simple, and it was simple because Smokey didn't know enough theory to know it shouldn't work. He hadn't been taught that magnets and electrical systems don't mix. He just tried it and measured the results. Smokey's legacy and the forgotten trick. Modern ignition systems don't need this trick because they're electronic. There are no points, no mechanical distributors, no shafts to wobble. But in the world of classic car restoration, Smokey's magnet trick has become legendary. Guys racing vintage Hemis, Pontiacs, Oldsmobiles, any engine with a conventional distributor have rediscovered this modification. Some use stronger magnets, rare earth neodymiums that didn't exist in 1955. Others stick with Smokey's original design: 8 cheap ceramic magnets and electrical tape. The results are always the same: smoother power delivery, higher RPM capability, better spark consistency. It's like finding free horsepower that's been there all along, just waiting for someone weird enough to try sticking magnets on a distributor. Smokey Yunick went on to become one of the most legendary mechanics in motorsports history. He built engines for NASCAR teams, Indy cars, and even helped GM develop their turbocharged engines in the 1970s. He held multiple patents for automotive innovations. He wrote books about engine building that are still referenced today. But when people who knew him talk about his greatest moment of pure genius, they don't talk about his fuel injection systems or his aerodynamic tricks. They talk about the day he walked into Western Auto, bought 8 magnets, and made Chrysler Hemis unbeatable for one glorious season. The 1955 Daytona Beach trials were the last time the old beach course was used for manufacturer speed runs. The next year, NASCAR started planning the super speedway, and beach racing began its slow death. That 300 that Smokey modified, nobody knows what happened to it. The dealer probably sold it to a customer who drove it for a decade and then traded it in. It's out there somewhere, maybe in a barn, maybe crushed decades ago. But for one weekend in February 1955, it was the fastest Chrysler in America, powered by ingenuity, skepticism, and 8 magnets from Western Auto. Conclusion: when weird works. The lesson here isn't about magnets specifically, it's about questioning assumptions. Chrysler's engineers knew that distributors needed tight tolerances and precision machining. They were right, but they were also trapped by conventional thinking. Smokey didn't have an engineering degree. He didn't have access to millions in development funding. What he had was the freedom to try stupid ideas. And sometimes, stupid ideas work. Think about how many problems in your life, in your work, in your hobbies, exist because everyone agrees on what the solution should be. Then think about what happens when someone who doesn't know the rules tries something different. That's where breakthroughs come from. Not from following the established path, but from being just weird enough, just curious enough, just stubborn enough to try the thing everyone says won't work. Smokey Yunick died in 2001 at the age of 77. His obituary in the New York Times called him racing's most legendary mechanic and its most famous rule bender. At his funeral, someone placed 8 small magnets on his casket. Nobody explained why, but everyone who knew the story understood. The next time you're stuck on a problem and all the conventional solutions have failed, remember Smokey Yunick and his magnets. Sometimes the answer isn't more complex. Sometimes it's simpler, weirder, and hiding in plain sight at your local hardware store. You just have to be willing to look stupid trying to find it. Because here's the truth about innovation. It usually looks stupid right up until the moment it works. And then, it's genius. Smokey Yunick understood this better than anyone. He didn't care about looking smart. He cared about going fast. And for one perfect season, before NASCAR banned it and the engineers dismissed it, and the world moved on to electronic ignition, he made Hemis faster than anyone thought possible using nothing but magnets, electrical tape, and the kind of weird thinking that changes everything. That's the real trick. Not the magnets themselves, but the willingness to try something nobody else would. The Chevy teams at Daytona had better funding, better equipment, better institutional support. But they didn't have Smokey. And in 1955, that made all the difference.